Welcome back, and thank you again for joining me for our Chapter 9 note videos. Today we're going to move on to geometric series. So the previous 2 days we've talked about arithmetic series. So we should know that the idea of series is you are adding the terms of a sequence. And in this case, we're going to be adding the terms of a geometric sequence. So with that, we have a new formula to know. Now again, don't panic, you'll get it on the test, but the idea is you need to know when and how to use it. All right, so let's look at the pieces that we're going to need. We're going to need the first term, we're going to need r, and we're going to need n. Now the thing you might find interesting, the thing that's different from the arithmetic one, is we actually don't need a to the n. That's not part of this formula. So something I think you might find interesting. So let's dive in and figure out how to solve these. So the first thing, we want to identify A1 and R. So A1 is easy. A1 is always going to be that first term. So here, my A1 is going to be 3. That R, the rate. So let's see, what are we multiplying by? So to get from 3 up to 6, looks like here we're multiplying by 2. So my R that I'm multiplying by is going to be 2. All right, so I'm going to construct the explicit formula so I can identify n. Because here I'm going all the way up to the last term. So I'm going up to that 3072. Let's see how I'm getting there. Well, again, the explicit formula says A1 times R, which is 2, to the n minus 1. All right, so let's divide that 3072. Let's divide that 3 off from both sides. All right, so I'm going to divide both sides by 3. So we'll just have 2 to the n minus 1. Now, here's where it gets a little bit tricky. All right, so we need to figure out what power of 2 that 1024 represents. So 2 to the 6th. Let's try that. Well, 2 to the 6th is only 64. So that's not what we're talking about. Let's try 2 to the 7. Well, 2 to the 7 is only 128. 2 to the 8th power is only 256. 2 to the 9th is 512. 2 to the 10. There. That is what we are looking for. So 1024 is actually 2 to the 10th power. All right, now here's where we're going to make a little jump. Now we're going to come back and hit this harder next chapter, but this jump, so if 2 to the 10 equals 2 to the n minus 1, then we're actually able to say that n minus 1 must equal that 10. So then really we can use that to show that n equals 11. All right, so we have our n. So now we have the 3 things that we need in order to create that sum. So A1, which is 3, times 1 minus r to the n. So 2 to the 11 over 1 minus r. So over 1 minus 2. All right, so we need to type that into the calculator really, really carefully. So 3 times 1 minus 2 to the 11. Again, we have to type that in really, really carefully. You should check your calculator with mine to make sure you are getting it. You'll get negative 6,141. On the bottom, 1 minus 2 is a negative 1. So in the end, that means you're getting a positive 6,141. All right, so a little bit intimidating, but it should be doable as long as you can follow those steps. Identifying A1 and R, and then using the explicit formula to get N, and then plugging it in to get Sn. So let's do another example. All right, so again, the first thing that we need, the first term and the rate. All right, so the first term, now when we're looking at a summation notation, the first term is when you plug 1 in to that formula. So 4 times and 1/2 is 0.5 to the first. So if you're looking for the first term, just plug 1 in, and you're getting 4 times 1/2 or 2. The rate. The rate is always going to be the thing that has the exponent. Okay, that variable exponent is always going to be the rate. So here the rate is 1/2. Or if you want to call that 0.5, that's fine as well. Now, the cool thing about this notation, is you actually already know what n is. All right, in this case, you don't actually have to find it. If you're going from 1 to 5, well, you know that you have 5 terms. So that makes it a little bit easier in that respect, okay? Because when you're using summation notation, you know exactly how many values for n you're taking, how many terms to the sequence you have. So here, the only thing we really have to do is plug all of it in. So let's take a look. Sn equals A1, so that's going to be 2, times 1 minus R, which is 0.5, to the n, so to the 5th power, all over 1 minus R, so 1 minus 0.5. All right, so we have it written in. Now here, again, you have to be very, very careful in how you use your parentheses. So I'm going to calculate the top first. 2 times 1 minus 0.5 to the 5th power. All right, and that is going to give me 1.9375 over 1 minus 0.5. Well, that just gives me 0.5. So again, calculate the top, calculate the bottom separately to make sure that you're not making any mistakes. So now I take that 1.9375 and I divide it by 0.5. That gives me 3.875 as my sum. All right, so let's keep going so we can get through this, shall we? So again, we're continuing on looking at finite geometric series. So let's take a look. A1, oh, R, and we need to find n. So again, A1 is always easy. It's that first term. R, what are we multiplying by to go from term to term? Well, this time we're multiplying by -2. And this time we're in luck because we can actually see the end of the sequence. So we can count up. There are 1, 2, 3, 4, 5, 6 terms. All right, so that's another nifty thing here. When you can see the beginning and the end, you can just simply count how many there are. So let's plug it into that formula now. So A1, -15, times 1 minus R to the n power. Now again, make sure you are using these parentheses appropriately. Then 1 minus r. All right, so again here, be very, very careful with how you're typing in these problems. Make sure you use both of those parentheses. And again, my advice, have the calculator out in front of you to make sure you are doing this right. So negative 15, 1 minus negative 2 to the 6th power. And you are getting 945. And on the bottom, 1 minus a negative 2 is giving you 3. So I take that and divide it by 3 and get 315. All right, so last one of this type. So we need A1, R, and N. So we need to plug in an N of 0 for our first term because it says we're starting at an N of 0. So 5 times negative 2 to the 0 minus 1. So 0 minus 1 is just going to be the negative first power. So again, let's type that in very carefully using those parentheses. So 5 times negative 2 to the negative first power gives me a negative 2.5. Again, my rate, my r, is always what carries that exponent. And then my n. Now this time be very careful. We're going from 0 up to 9. We're used to going from 1 up to a number. So you have to be really, really careful here. So 0 up to 9 is actually going to be 10 terms. All right, because 1 to 9 would be 9, so going from 0 to 9 would be 10 terms. All right, and now we're ready to plug it into our summation formula. A1, which is negative 2.5, 1 minus r, which is negative 2, to the n, which is 10. And again, make sure you're using those parentheses over 1 minus r, which is a negative 2. So we type this in carefully. I'm going to take care of the top first. And on top, I am getting 2557.5. And on the bottom, I'm getting 3. So I do that division, and I get my total being 800, 500, or 852.5. So that is my final sum. And again, it's a lot of just practice, learning how to use these formulas, how to type them into the calculator correctly. So please make sure that you're following along and checking that you are getting the same numbers that I am. All right, so now let's look at a fun little story, a fun little word problem. So a famous story involves a soldier who rescues his king in battle. The king grants him any prize within reason from the riches of the kingdom. The soldier asks for a chessboard with a single kernel of wheat on the first square, 2 kernels of wheat on the second square, then 4, then 8, and so on for all 64 squares of the chessboard. The king decides that the request is reasonable. According to the story, how many total kernels of wheat did the soldier request? All right, so fun little problem here. So we're starting with 1 kernel, then doubling it again. So we're having this doubling pattern all the way up until n is 64. All right. All right, so our first term? Well, we're starting with just 1. What's our rate? What are we multiplying by? Well, I think it's easy to see we are doubling it. We're multiplying by 2. And how many terms are in the sequence? Well, it says there's 64 squares to that chessboard. So we're going to have 64 terms. All right. So this one, actually, this word problem was pretty simple in setting up what's happening. So let's find out what that sum is. How many kernels is he actually going to get this way? So we're starting with 1, then 1 minus r to the n. So 2 to the 64 divided by 1 minus r. So now when you try to do this on the calculator, you're going to get some nonsense like this. It's going to tell you the sum is 1.8446744407 e to the 19. Now, you may have seen this in Expo. This may have happened once or twice. What that notation really means is scientific notation. So it's saying take 1.84 times 10 to the 19. So that's telling you move this decimal place over 19 times to the left or to the right to increase this number. So basically it's saying take this number and then you still need 17 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So again, in this case, the number itself isn't that important. It's the fact that how absurd that number got, just how big that number is the critical piece to this story. All right? So, a huge, huge, huge amount. All right, so thank you for joining me for this video. Now, please make sure you have all of that written down in your notes so you can come back ready to do your practice work tomorrow.